Imagine if your phone's autocomplete could write an essay, debug code, explain quantum physics, and help plan a business. That is the basic shock of a large language model. An LLM, or large language model, is a computer system trained to work with language. It learns patterns from huge amounts of text, then uses those patterns to generate useful responses. LLMs matter because language is how we store and share a lot of human knowledge. If a machine can handle language well, it can help with writing, studying, coding, searching, summarizing, brainstorming, and explaining. A normal app usually follows fixed instructions. If you press this button, it does that thing. An LLM is different. You type a request in normal language, and the model creates a response word by word. At the center of an LLM is a simple-sounding task. Given some text, predict what should come next. That may sound small, but when it is scaled up with enough data and computation, it can produce surprisingly flexible behavior. Think about the sentence, "The cat sat on the." You can probably guess the next word might be mat. You are using experience with language. LLMs do something related, but at a massive scale, and with math instead of human understanding. LLMs do not usually read text exactly as whole words. They break text into pieces called tokens. A token can be a full word, part of a word, punctuation, or even a space, depending on the language and the system. When you ask a question, the model sees a stream of tokens. It then predicts the next token, adds it to the stream, predicts the next one, and continues until the answer is complete. Training means showing the model many examples of text and adjusting its internal settings so its predictions get better. It sees patterns in grammar, facts, style, code, reasoning steps, and conversation. During training, the model is not storing every sentence like a hard drive. It is learning statistical relationships. It learns that some words often appear near other words, and that certain kinds of questions usually call for certain kinds of answers. Inside the model are billions of numbers called parameters. Training changes those numbers little by little. Each change helps the model become slightly better at predicting text across many different examples. Small predictive text can finish a phrase. A large language model can follow instructions, compare ideas, translate, write code, and explain concepts. The basic prediction task stays similar, but scale makes the behavior much richer. This is why people say LLMs seem to reason. They have learned many examples where language contains steps, plans, evidence, corrections, and conclusions. When prompted well, they can produce responses that look like structured thinking. But reasoning-like behavior is not the same as human thinking. An LLM does not have beliefs, senses, goals, or lived experience in the human way. It generates text based on learned patterns and the context you give it. If this kind of clear tech breakdown is useful, consider subscribing. We explain AI, crypto, and future technology in plain English, so you can understand the tools shaping the next decade. After the main training stage, many models go through extra tuning. They may be trained to follow instructions better, refuse unsafe requests, and give answers that are more helpful in conversation. The prompt is the text you give the model. It can be a question, a command, an example, a document, or a role. The model uses that prompt as context for deciding what text should come next. An LLM can only pay attention to a limited amount of text at one time. This limit is often called the context window. Text inside the window can influence the answer. Text outside it is not directly available to the model. Because of this, a model may lose track of details in a long conversation or long document. Some systems add separate memory features, but the core model still works by using the current context it can see. When the model answers, it does not pull a finished paragraph from a shelf. It builds the answer step by step. At each step, it chooses a likely next token from many possibilities. Many LLMs can produce different answers to the same prompt. This happens because the system may allow some randomness when choosing the next token. More randomness can make answers more creative, but also less predictable. An LLM can sound confident because it has learned the style of confident explanations, but it can still be wrong. It may mix up facts, miss recent events, or fill gaps with text that sounds plausible. When a model invents information, people often call that a hallucination. The model is not lying on purpose, it is producing a likely sounding answer that may not match reality. This is why important answers should be checked. For medical, legal, financial, technical, or current information, an LLM should be treated as an assistant, not as the final authority. LLMs are especially strong at tasks where language patterns matter. They can summarize long text, rewrite a paragraph, explain a concept at different levels, draft emails, generate ideas, and help understand code. They struggle when a task requires guaranteed accuracy, private information they cannot access, physical experience, or perfect multi-step reliability. They can help reason through a problem, but they can also make subtle mistakes. One useful analogy is a librarian who has read a huge library, but does not open the books while answering. The librarian has learned many patterns from the books, but can still misremember or confuse details. Another analogy is a map. A map can be extremely useful, but it is not the territory itself. An LLM contains a compressed model of patterns in language, not direct access to reality. LLMs feel natural because conversation is just another kind of text pattern. They have seen questions, answers, corrections, jokes, arguments, tutorials, and explanations, so they can adapt their style to the conversation. If you say, "Explain this like I am new to the topic," the model changes its response style. If you say, "Make it shorter," it compresses. If you provide examples, it can imitate the pattern you showed. On their own, LLMs generate text, but many products connect them to tools, such as search, calculators, code runners, calendars, or databases. With tools, a model can become part of a larger system that can take useful actions. The word large usually refers to the scale of the system. Large models often have many parameters, are trained on large datasets, and need serious computing power. Bigger is not automatically better for every task, but scale has been important in their progress. LLMs can work with many languages, but performance can vary. Languages with more high-quality training data are often handled better. This is one reason data quality matters, not just data size. Because models learn from human text, they can also learn human biases, stereotypes, and blind spots. Responsible design tries to reduce harmful outputs, but no system is perfectly neutral. Another practical issue is privacy. If you paste sensitive information into an AI tool, that information may be processed by the service behind it. The safe habit is to avoid sharing secrets unless you fully understand the tool's privacy settings. A good prompt gives the model a clear task, useful context, and the desired format. Instead of asking, "Tell me about climate," you might ask for a simple explanation of climate change for a high school student in 5 short paragraphs. The best results often come from treating the LLM like a collaborator. Ask it to draft, then revise. Ask for alternatives. Ask what might be missing. Ask it to explain its assumptions. Then check the important parts yourself. So what is an LLM? It is a large system trained to predict and generate tokens of language. From that simple foundation, it can produce useful explanations, code, summaries, plans, and conversations. LLMs are becoming a new interface for computers. Instead of only clicking menus or learning commands, people can increasingly describe what they want in normal language. That changes how we learn, work, and create. The healthiest way to understand an LLM is to avoid two extremes. It is not magic, and it is not just a toy. It is a powerful pattern machine that can be very useful when you know its strengths and limits. If you still have questions about LLMs, drop them in the comments. And if you want the next explainer to cover prompts, AI agents, neural networks, or how model training works, suggest the topic below.